Hi, good morning one and all. I am Lakshmi Sudha, Associate Professor in Mathematics, Department of Humanities and Science. Today I am going to teach discrete distributions. Before we know that, some basic definitions of the probability. What is probability? Probability means chance of occurrence. Suppose you may get first class. It may rain today. The second one is random experiment. What is random experiment? The random experiment is conducted number of times, several times. The result is not certain. The result is depending on the several possible outcomes. It is called random experiment. The next definition is trial. Any random experiment is called trial. I want to toss the coin. That is trial. Event. The total outcomes in any trial, in any random experiment, is called event. It is denoted by capital E. Now, there are types of events. First one is equally likely event. What is equally likely event? There is an equal chance of the occurrence in any trial is called equally likely event. For example, tossing a coin. It may be head or it may be tail. There is an equal chance of the occurrence. It may be head or tail. That is called equally likely event. Now, exhaustive event. What is exhaustive event? Exhaustive event. The total possible outcomes in any random experiment is called exhaustive event. Tossing a coin. Now there are two possible outcomes in a single toss. Now two. Mutually exclusive events. Mutually exclusive event. Mutually exclusive event means if the happening of the any event excludes the happening of the another any event of the any trial. That is called mutually exclusive event. Now, what is the mathematical definition of the probability? Now, E is any random experiment. M are mutually exclusive events. And N be the total possible outcomes. Now, the probability of P of E equal to M by N equal to the total number of elementary events by the total number of exhaustive events. Exhaustive events is called probability of the mathematical definition. Now, next we can see non-occurrence of the probability. Occurrence means it will be happened something. Non-occurrence means it is not possible. Now, non-occurrence of the probability. It is denoted by P of E bar equal to Q equal to N minus M by N. N means total exhaustive events. M means possible outcomes. M means exhaustive events by total number of events equal to 1 M by N minus M by N. The final value Q equal to 1 minus M by N means P. Therefore, P plus Q equal to 1. The total probability is always equal to 1. can see sample space. What is the definition of the sample space? Sample space means the total possible number of events in any random experiment is called sample space. It is denoted by S. Tossing a coin. Tossing a coin, it may be head or it may be tail. The total possible outcomes are 2. Throwing a die. Throwing a die means 1, 2, 3, 4, 5, 6. Now total possible outcomes are 6. This is the total sample space. Now another example. Tossing 2 coins. Now tossing 2 coins, it may be head or tail. It may be head or tail. 2 coins. The total sample space S equal to H T T H T T. Now here total possible outcomes are 4. Next example, tossing 2 dice. Sample space S equal to 1, 2, 3, 4, 5, 6. How many times tossing a die? 2 times. Means we have to write down 2 times in tossing a coin. Combine all the terms. We are getting the total cases. Now 1, 1 possibilities. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. Now the next combination 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Next one 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Next one 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Next 5, 1, same like that 6, 1. Last case is 6, 6. 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. 6, 6, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. The total possibilities are 36. Now tossing 2 coins and 2 dice, the total cases are 36. The next we can see exams of the probability. The first probability is when E is any random experiment, it should be never negative. And second probability is P of S equal to 1. The total probability is always 1. P always 1. P plus Q equal to total probability is 1. P never negative. Now third property, E1, E2 are 2 designed events. Designed means intersection should be 0. Now probability of E1 union E2 equal to P of E1 plus P of E2. Already we know that the definition of theorem, addition theorem of the probability. What is the addition theorem of the probability? P of E1 union E2 equal to P of E1 plus P of E2 minus P of E1 intersection E2. Now E1, E2 are the 2 disjoint events. The intersection should be 0. Then the value is P of E1 union E2 equal to P of E1 plus P of E2. These 3 are the examples of the probability. What is random variable? definition is, what is random variable? Random variable. X is a random variable whose value can be determined any random experiment. Now, F is mapping from X to R, total real number system. For example, tossing a 2 coins. Tossing a 2 coins means S equal to HH, HT, TH, TT. Now, the sample space S equal to sample point S1, S2, S3, S4. Total sample points are 4. Tossing a 2 coins. Now, here we can find getting a head. We can find the getting a head. What is the range of X? It may be 0 heads, it may be 1 head, it may be 2 heads. Means here X of S1 equal to, what is the value? Here X of S1, here 2S, 2 heads are there. X of S2 equal to 1 head. X of X3 equal to 1 head. X of S4 equal to 0 heads. Observe all the values. Here X of S1 is 2, means 2 heads. Here H comma H are 2. X of S2 is single head. X of X3 is also single head. X of S4 is there are no heads, means the value becomes 0. This means the X ranges 0, 1, 2. And the range of X equal to 0, 1, 2. This should be mapping to total real number system R. Next, what is probability distribution? Probability distribution. Probability distribution means X is any random variable whose takes the values x1, x2 and so on, xn terms. P is the probability of the values p1, p2 and so on, pn. Then the probability is P of xi with corresponding values of the probability of the corresponding values of the x. Probability is ever negative. It is denoted by P of xi. Probability is total P of xi is ever negative, greater than or equal to 0. Second, it satisfies the following conditions. Second one is summation of P of xi equal to 1. Total summation, adding all the values, we are getting the summation value is 1. These are the probability distribution conditions. There are two types of the distributions. First one is discrete probability distribution. Discrete probability distribution. A random variable capital X takes the only finite values. Is called a discrete random distribution. Finite values means, let us take the, for example, previous already I told that one, tossing a coin. Tossing a coin means the sample space S equal to H comma T. Only finite values 2. That is one of the example. Throwing a die, playing a cards. Playing a cards, the total number of playing the cards 52. Red color playing cards are 26 and black color are 26. Now, these are the finite values. Whatever the finite value we have to take, that is considered to discrete probability distribution. Another one is continuous random variable. Continuous probability distribution. Continuous probability distribution means X is a random variable which takes the corresponding values of the probabilities P1, P2 and so on Pn. Then the X takes the values in continuously. Example, age is continuous, time, temperature, height. These are the examples of the continuous probability distribution. Now, see, depending on the first, discrete probability distribution depending on the problems. Next, continuous random variable depending on the problems. Now, the next definition is, what is mean? Mean or expectation. Mean or expectation. What is mean? Capital X is the random variable which takes the values x1, x2 and so on xn. And corresponding probabilities P1, P2 and so on Pn. Now, the sum of the product of different values of the different values of x with corresponding probabilities. With corresponding probabilities is called mean. It is denoted by mu or E of x. X is the random variable which takes the values in the finitely. Why? Because finitely means discrete distribution values. P1, P2 and so on Pn are the corresponding probabilities. The sum of the product of the different values of x with corresponding probabilities is called mean. Now, capital X is the random variable, x1, x2 and so on xn, finite values. P is the probability, P1, P2 and so on Pn. Means, observe the value, see the table. Now, mu equal to summation P of xi means xi into. Ante P of means x1 into P1 plus x2 into P2 and so on xn into Pn. That is called summation xi into Pi. That is called the mean of the probability distribution. Okay. Next we can see variance. What is the variance? Variance characterizes variability between the two distributions with the same mean but can still have some difference. That is called variance. It is denoted by sigma square equal to E of x square minus E of x whole square. E of x square minus mu square. Otherwise, it will be noted another notation E of x whole square. These are the similar definitions to variance. Variance characterizes variability difference between the two mean of the distributions. Now, this is the definition of the variance. Now, next see the example. One problem. X is a random variable which takes the finite values. 2 dice are thrown. 2 dice are 2 points. 2 points are thrown. Sorry. 2 points are thrown. X takes the maximum value. X of a comma b equal to maximum of a comma b find probability distribution. Second one is mean value. Third one is variance value. We can find 3 problems here. Observe. Find first probability distribution table, next mean, next variance. 2 points are thrown. using the favorable case x of a b comma b equal to maximum of a comma b. That is the given condition. Now observe this problem. Dice are thrown, points of dice are thrown. 2 dice are thrown. Now take one example. 2 dice are thrown. Then x is the maximum value of a comma b. Now find the probability distribution, mean and variance values. 2 dice are thrown. The sample space s equal to how many values? 36. Here condition is there. X of a comma b equal to maximum of a comma max of a comma b. Here x takes the values 1, 2, 3, 4, 5, 6. X takes the values, finite number of values 1, 2, 3, 4, 5, 6. Now we have to find the corresponding probability values. P of 1, P of 2, P of 3, P of 4, P of 5, P of 6. Now, using the condition maximum of a comma b condition. First one. Let first one x equal to 1. Probability of 1 comma 1. Already previous example, total throwing a 2 dice, total cases are 36. Means 1 comma 1, 1 comma 2 and so on, 1 comma 6 like that. We have to take the condition of which one? X of a comma b. Of the alternate x of a comma b, the pair of the values. Maximum of a comma b. Means 1 comma 1. Means the 1 comma 1, how many cases are there? Maximum value compulsory 1. And only one favorable case, total cases are 36. At x equal to 2. At x equal to 2 means here 1 comma 1, 2 maximum values 2. 2 comma 1, 2 comma 2. Now how many favorable cases? 3 favorable cases. Means probability of P of 2 equal to 3 by 36. Next. At x equal to 3. Maximum value is 3. 1 comma 3. 3 comma 1. 2 comma 3. 3 comma 2. 3 comma 3. In the previous example already I told the 1 comma 1, 1 comma 2 and so on, 1 comma 6. 2 comma 1, 2 comma 2, 2 comma and so on, 2 comma 6. 3 comma 1, 3 comma 2, 3 comma 3 and so on, 3 comma 6. Now here the x equal to 3 is the maximum value. 1 comma 3, 3 comma 1, 2 comma 3, 3 comma 2, 3 comma 3. Now favorable cases are 5. Total cases are 36. And a probability of 3. Here 3 cases are completed. 3 events. Next remaining 3 events we can calculate. We can observe the values. At x equal to 4. At x equal to 4, how many cases? 1 comma 4, 4 comma 1, 2 comma 4, 4 comma 2, 4 comma 4, 3 comma 4, 4 comma 3. Total cases 7 cases. Total cases 7 cases. Probability of 4 equal to 7 by 36. Next case. At x equal to 5. The number of possible outcomes. Then what are the cases? Maximum value 5. Maximum value 5 means 1 comma 5, 5 comma 1, 5, 2, 2, 5, 4, 5, 3, 5, 5, 3, 4, 5, 5, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 5, 5, 9. Total cases are 9. 9 favorable cases. Probability of P of 5 equal to 9 by 36. Now, first 5 cases are completed. Last case. Last case, x equal to 6. What are the favorable cases here? 1, 6, 6, 1, 6, 2, 6, 3, 6, 4, 4, 6, 3, 6, 5, 6, 6, 5, 6, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 3, 3, 6. 2, 6. Now total cases are 11. Probability of x P6 equal to 11 by 36. Now we can write down the probability distribution table. Probability distribution table is x value, P of x value. Here 1, 2, 3, 4, 5, 6. 1 by 36, 3 by 36, 5 by 36, 7 by 36, 9 by 36, 11 by 36. These are the probability distribution table. Okay. Now, this is the calculation of the probability distribution table. Using this table, we can calculate mean value and variance value. Okay. Next class, we can see the remaining calculations. Thank you. Thank you very much. Meet you later.